All right, let's get things started. I'd like to start off by saying thank you, everyone, for coming. My name is Cody Armstrong, and of course, we're talking about multi-part modeling today. So we're going to cover all the different details of modeling multiple parts together in Onshape. As I always say with these webinars, we really encourage you to ask any questions that you have. So you have a questions dialog, and you go to webinar panel. Feel free to type in any questions that you'd like. I'll do my best to stop from time to time and answer them. Also, stick around. If I haven't answered your question at the end of the webinar, I'll make sure to stop and address them all. So multi-part modeling, that's what we're going to get into today, and I have a number of different examples to show you. Before we get into the topic of today and multi-part modeling in particular, there are a few things I like to mention about Onshape in general. So if you're new to Onshape or you're just getting started, I always like to point out our mission statement, and that is getting everyone working together with CAD on any device, anywhere. And this means iPads, iPhones, Android tablets, Linux, Chromebooks, Mac, Windows. You know, if you have accessibility to the web, you have accessibility to your CAD data. And it really doesn't matter what particular device. This also means working collaboratively, right? Because the data is in the cloud, multiple people can work together in the same assembly. There's a lot of benefits to the real-time collaborative benefits of Onshape. So everyone working together with CAD on any device, anywhere, that's our goal. Now, some other things I always like to point out is we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's three categories. It's parts, assemblies, and of course drawings. And we do have all three major pieces that make up a professional 3D CAD system. The other things that I always like to point out here, that especially that are unique, is that Onshape evolves very quickly. So you're going to see roughly every 3 weeks new functionality coming to Onshape. You don't have to do anything. There's nothing to update or install. It's just there. You're going to see it the next time you log in. So new functionality comes very quickly in Onshape. The things I always like to point out that are, especially if you've come from another CAD system, is with Onshape version control is built in. There is no concept of a PDM system necessarily that manages check-in, check-out. Those issues go away. And version control is built into the core of Onshape. So it's not an afterthought or something that has to be managed separately. The other things that are worth mentioning is we can import and export or read and write a lot of the common CAD formats that are out there. So STEP, IGES, Parasolid, many of the neutral file formats, including some of the native formats like SolidWorks parts and pack and go assemblies, for example, or Inventor parts. So we have a number of different formats that we can import and export. Okay. It also makes it a great application if you're trying to use Onshape alongside an existing CAD system. All right, so my last bullet point here is entirely new methods of collaboration, and I mentioned this just briefly earlier, but if you haven't shared your document and done some real-time collaboration with another user, it's really one of the biggest benefits to Onshape and the cloud-based CAD application is the fact that multiple people can work together in the same document, much like Google Docs, for example. So you have that same feel, that same atmosphere in CAD. So those are my bullet points. Those are the things I always like to mention about Onshape in general. If you're new to Onshape, just kind of give you an introduction to who we are and the things that we feel are really important. Now, what we're going to talk about today, the goal really is to introduce you to multi-part modeling. So if you've spent some time in Onshape, maybe built some parts here and there, multi-part modeling is just a touch more advanced than just our standard essentials webinar. And the idea behind it is you're building what's often referred to as top-down, where you're building multiple parts with context relative to each other. And there's a number of different examples I can give you of this. I've highlighted 5, and I just think that these are probably the 5 most common. But by far, these are not the only examples I could give you of multi-part modeling. As I mentioned before, importing is a big part of this. Working with external data or data coming from other common CAD formats is important. I'll walk you through that process as well. It's very simple. As I mentioned, earlier, really encourage you to ask any questions that you have. I'll do my best as we're going through this to answer any questions that come up. Okay, so one last slide. What is multi-part modeling? And it sounds pretty standard, right? Multiple parts together. But there's a number of useful ways we can use this. So, of course, multiple parts built in the same part studio. And this is just something, for those new users, multi-part modeling means you're building multiple parts in one part studio environment. It's useful for a number of different situations, but probably the most common example is creating dependencies between parts. It allows you to build better design intent in, and it gives you a lot of flexibility in how you build your models. Now, there are a number of powerful multi-part techniques that can be used. I want to highlight probably some of the more common ones here today. That's my point again. There's many examples I could give you. I'm just going to try and highlight some of the more common ones. A question that's come up: is there a way to check if the parts in the assembly are going into each other, interfering with each other, I assume? And the answer is yes. If you do a section view, you'll see any interfering parts in bright red. So the interference is in the section view command. Do a section view, and anything interfering will show in bright red. Okay, so some examples. Probably one of the most common examples of multi-part modeling is a technique called bridging, and it's something that the average user has done and may not even have been aware that it was multiple parts at the time. And it's just that you create a part in space and another part in space, and initially they're not joined with anything. And so at the moment, they're multi-parts. They're two different parts, and then later you bridge them or join them together with another feature. I'll show you an example of this. Many users have done this and not even been aware that it was a multi-part technique, probably one of the more common. Now, one of the most powerful examples I can give you is the next one, and that is building parts with relationships to each other. If I build in context with contextual relationships to each other, it means that I can change things very quickly and update many parts at once, and because of the construction, because of the way it was built. So I'll show you a simple example of this, but definitely a very powerful modeling technique. Now, the last example I have is using multi-parts is essentially tools, just tools to subtract or remove or to pattern solely for the purpose of construction, just to shape the part. So there's examples where you're going to build a part and its sole purpose is just to be removed from the finished end result. So multi-part is tools. I have an example of that as well. Really, you're using Boolean functions to subtract your part or tool from the model. All right, so let's jump into things. Now, as I mentioned before, one of the most common examples to start with is what's often referred to as bridging. So bridging, I have a real simple example of it. As I mentioned before, this is one of those that's so common, in fact, that most users aren't aware that they're doing it. So here's an example of bridging where I have a squeegee I've designed, and I have the handle, and I have the base where it attaches to the actual arm, but I don't have the piece that joins them. Right now, these two are separate parts in my part studio, but in reality, in the finished product, this is all one piece. So this is a good example of bridging. Really, if you have any part separated in space by another part that you later join, that's considered bridging. Right? And the important thing I always like to mention here is for the new user, there's a misconception that you have to work in one direction. Like I have to work left to right or right to left or up to down because everything has to be attached to the last thing I created. And that's not the case at all. You can build parts in space and then later join them with features similar to what I'm doing here. So very simple. In fact, it's not much different until we get into the actual dialogue where we tell it to merge. And so let's walk through that process. Now, in this case, I have a loft that joins the handle to the base here. So I'm going to do a loft. We'll select the face and we'll select sketch 16, which is this rectangular sketch here. And we'll use a few guides to define the shape of the loft. Now, up to this point, it's just a typical loft, right? You do a loft, you select your profiles, any guides or any kind of end conditions that you'd like, and you hit OK. Now, if I hit OK right now, it assumes that this is a new part. Okay, so definitely worth pointing out, in this case, it's defaulting to a new part. But what I'd like is it to merge with the handle and this piece, the round piece here. To accomplish that, instead of creating a new part, we're going to choose Add. And so this is when we get into defining what we want to merge this feature with. So as soon as I hit Add, you're going to see Merge Scope appear. And basically, this is what parts do you want to merge this feature with. So in this case, I want to merge it with the handle and this round boss. So I select those two parts, and now all three of those that it was going to be three separate parts are now one. right? I hit the green check OK, and now if I left click on part 1, you'll see it's the entire squeegee arm. Okay? So that's the key thing that I wanted to point out is in any feature, by default, it may be set to add to create a new part, but you can set it to add and then specify what parts you want to merge this feature with. So very common technique when you're bridging, when I have this part in space and another part in space and I want to join them, you need to specify what parts do you want to merge together. Okay, so real simple example of bridging. The next one that I have, probably one of the most common examples I can give you, or simple examples I can give you, of building dependencies between parts. And so building multiple parts together, one of the biggest benefits to it is the fact that you have, you can have one sketch or one entity, one thing that drives everything. And so it's a very powerful technique, especially when you're building, small design variations, for example, where it's very similar, but maybe a few dimensions have changed. And so it allows me to update many things at once. And so it's a very powerful modeling technique. This is, building dependencies between parts. So some things I want to point out before I get into this. The first, I have a sketch here. The sketch has many overlapping contours. And if you come from a traditional CAD system, those can sometimes cause issues. And Onshape, it's actually a benefit to us. We can take these many overlapping contours and define different parts between them or one single part. You really have the flexibility to define that on the fly. Now, by default, if I just, for instance, I want to start extruding my first arm here, if I select the sketch and hit extrude, it assumes that you want to extrude the entire thing, right? So if you go straight from your sketch to the extrude dialog, Onshape assumes that you want to pull the entire thing out for your sketch. However, you don't have to use the entire sketch. You can hit the X here, and I can select individual contours, right? So we'll punch in a depth, 100 thousandths, and then I just go into the actual sketch and just start left-clicking individual contours, right? So I can define which pieces of the sketch I want to use for this first part, right? So now I've defined the extrude for my first arm. I hit the green check, and there we go. I'll do that again. We'll do another extrude using the same sketch. And so this is another little bit of a shift from a traditional CAD system where you have one sketch, one feature. And Onshape, one sketch can drive many different features. So in this case, I'll extrude. Again, we'll do 100 thousandths. And I'll select the bottom arm as the entity I'd like to extrude. Some things I want to point out. Notice in this case, the extrude direction is going up, right? So it's going in the same direction as the initial feature. So it defaults to add. It assumes that you want to merge this extrude with this extrude to create one part. But in my case, I don't. So, essentially the opposite of what we were trying to do before, where we're trying to merge them, we're trying to add. Now we're going to set this to new, right? I want to create a new part out of this feature. Now, in my case, I want to reverse direction, so we'll reverse it. And now I have two arms extruded in two different directions. Okay, and the big thing here, driven by the same sketch. So now I have two parts, and the indication you'll see in the feature list here, part 1 and part 2. So real simple two-part example. Let's take this one step further. I'm going to go ahead and start a new sketch and sketch a few circles here. Notice that I'm constraining these sketch entities to the previous sketch. So I'm sketching a circle, but I'm attaching it to the center point of this sketch from the first sketch, the circle from the previous sketch. So I'm still constraining everything by that first sketch. That sketch is still what's driving the entire design. Okay. So I have two circles. I'll hit OK. We'll do another sketch, but this time, instead of being on the top arm, we'll create a sketch on the bottom arm. So just below it, new sketch, same thing, we'll sketch two circles and constrain them. Again, I'm just creating constraints to that very first sketch, the idea being, it will automatically update. Right? Now, one thing I want to point out is the question often comes up, well, what if I want to create, two parts and have them the same diameter? Or what if I want to constrain, two parts relative to each other? Can I do that? And the answer is, in particular in this scenario, because the planes, these two pins, for example, I want them the same diameter. They're drawn on parallel planes, so I don't need to use anything like a variable. I can just set the two circles to equal. Okay, and now these two parts will have the same diameter. So building a bit of design intent in here as well. Now that works well because they sit on parallel planes. If they weren't, you would need to use something along the lines of a variable. Okay, so now we have 4 circles from 2 different sketches. I'm going to go ahead and hit OK. I'll go to extrude, and I'll select both sketches. Okay. Now I'm extruding 4 parts at once. So you can use any piece of a sketch, combinations of sketches to extrude. You don't have to follow the rule of one sketch, one feature, one sketch, one feature. So I have 4 parts being extruded at once. In my case, I want to reverse the direction and go up to face using a plane that was created earlier. Okay. So I just want to extrude this to what I refer to as the midplane, which is the center of my clamp. So I have these 4 parts. You'll notice in my part list here, I've gone from 2 to 6. Green check OK, and now I have my pins modeled in place. Now you'll notice if you look really closely that they're overlapping. You'll see kind of the jagged colors differences between them. That's indication that the parts are overlapping with the 2 arms. What's really neat about this is the fact that I modeled them together means that I can just subtract one from the other. If I had modeled all these pins by themselves, I would need to come back here and measure the holes, then go back to the pins and cut them based on that measurement. Because I've modeled them together, I can use simple Boolean tools to subtract one from the other. So I can use Boolean, subtract, and say, okay, I want the tools to be the 2 arms, right? And the targets, or the parts that are being modified, are the 4 pins. Okay. So I'll select the 4 pins. You'll see a preview of the cut into the pins. Now, a very important thing to point out is in the Boolean, by default, it does not keep what it calls the tools. So in this case, I have these arms. These arms are actually, supposed to be in the design. I want to check keep tools. Now, if the part is just there for purpose of construction, you can leave that unchecked, and that will eliminate, the tools. But in this case, I'd like to keep them. Green check. And now if I hide those 2 arms, you'll see the pins are now notched or cut to match, the arms. So another benefit of multi-part modeling is it's very easy to just subtract one part from another. Okay. Now, another benefit to this is, let's just say, in fact, let's go ahead and hide those parts again. Let's just say that, for instance, I needed to mirror these pins. I can, again, in the single part studio, select mirror and just window select all 4 pins, select the mirror plane as the bottom, and now I'm mirroring all pins at once. So, definitely worth pointing out, you can, mirror multiple parts at once. You can extrude multiple parts at once. So you can build really quickly using this technique. And I can even, in the mirror, do the Boolean and then select merge scope and merge all the pins in the same command, right? So I don't have to go to a different dialog to do that. So definitely one big benefit. Question that's popped up was offset for assembly clearance. Do you have the same offset for both on each pin? You do have offsets. You can specify offsets. It's worth pointing out that, in the Boolean, in this case, I can check offset, right? And specify individual faces to offset. Okay. Now you have offset that allows you to offset individual parts, or you have offset all, which will offset all the pins in this case with the same value, right? So there's a 10,000th offset, for example. So you can offset in the actual Boolean in this example. Okay, so let's move on. So that's the simple example I have for building multiple parts with relationships to each other. Now, the biggest benefit to this, of course, is, now that I have this one design, remember this one design is really driven by this one sketch. If I edit the sketch, I can now change, individual dimensions inside of this one sketch and drive multiple parts at once, right? So I don't have to go back and forth between multiple pieces. It's just a more, simple way of working with it, right? So change a few dimensions, green check OK, and everything automatically updates. So notice the new pin locations, the new arm length, everything changes without much effort, right? So again, building some design intent in, making it very quick to update and make changes. All right, so that's building parts with dependencies to each other. Now I have a few other examples. In particular, the next one is using Boolean tools. Okay, so the Boolean tools, I've already shown this just briefly, give you a lot of powerful capabilities. And the example I always like to show here is, I have this bolt and I would like to, pattern it. But more importantly, I'd like to subtract it from the seal. So I don't have to actually, use a hole, cut a hole, and then tap the hole. I can just subtract the bolt from it and accomplish the same thing. So let me show you what I'm talking about. Let's do a quick section view. Okay. You'll notice, and this question came up earlier, how do I know if things are overlapping with one another? In the section view, you'll notice that anything overlapping shows up as bright red. So here I have this bolt that's bright red, and that means that the bolt is overlapping with, in this case, the end cap. And what I'd like to do is, instead of going in and cutting holes into this part and doing individual swept cuts for each thread, is just to simply subtract the bolt from the hole, right? So you can subtract the bolt from the hole, and it will give you that intended result without much effort. So let's do this. We'll do, again, a Boolean subtract, right? The tool will be the bolt. The target is the end cap. Okay? Very important, again, in this case, I want to keep it, so I check keep tools or keep the bolt. Green check OK. And now if I do a section view, again, notice that it's no longer red. Now I've cut that hole into the seal retainer, and all I used was the bolt that drives it. Okay. Now let's take this one step further. Now the question often comes up: can you do things like circular patterns of parts at the assembly level? And the answer is no. But you can do that stuff at the Part Studio level, and that's really where it's intended. So I'm going to go ahead and delete that last Boolean. And what I'd like to do is, instead of subtracting this one bolt from the end cap, I'd like to pattern it and then subtract all of them. So for this, we'll use a circular pattern. So in the Part Studio, I can pattern parts. We'll select circular pattern. Entity to pattern is the bolt. Axis of pattern, I can just use any cylindrical face as a reference. I want 6 of these, okay, with equal spacing over 360. Okay. So I have 6 bolts in the correct hole locations, right? Green check OK, and now I have all the bolts in place. Okay. Now if I do a Boolean subtract, I can specify all the bolts and subtract them from the end cap at once. Okay. So you can do things like patterns of parts. It's at the Part Studio level. Okay. Again, keep tools. Okay. And now just one more section view. Right, now you'll notice that I'm also cutting holes here in the bottom as well. Okay. All right, so that is the circular pattern of a bolt. The main thing I want to point out there is using the bolts as tools, right? Or I pattern the bolts and then I use them to subtract from the main entity, the thing I'm mostly concerned with. All right, so let's move on. Now, there's one last thing I like to show with this model, and it's one of the biggest benefits to modeling in multiple parts, is that when you build your assembly, you have the ability to insert all the parts at once. Right, so because I built this entire cylinder in one part studio, all 40 parts or 36 parts, when I insert it into my assembly and I want to test the motion out, I can insert all the parts at once, and they all come in the same orientation that I modeled them. Now, it's a bit deceiving. They're not actually mated, right? So if you left click and drag, they move. But what's really nice about this is I don't have to go in and individually mate them. Because much of this cylinder is static, it doesn't move like the tie rods and all these nuts and things like that. They don't really move. I can just group them together. So another big benefit to doing it this way is now I can group all these parts together and I don't have to mate them. Right? It just saves time. So for anything that doesn't move, anything that doesn't need motion, you can just simply group it. And then you don't have to worry about going in and defining individual mates to locate each bolt, for example. So very quickly, green check group, okay. And now I've got all these parts grouped together. They act as one, right? So it's a very easy way to piece in. And you may have assemblies with, 40, 50 parts and one mate because of, the technique of building everything together and then just grouping anything that doesn't move in your assemblies. Okay. So I know it's a bit of an off topic, the assemblies in general, but one of the biggest benefits to modeling like this is when you go to the assembly, you don't have to do a lot of mates. Oftentimes it's just a few and then everything else is grouped together. All right, so moving on. The next example that I have is derived parts. Now, derived parts are a pretty special use case, but it's one that I think often many engineers fall into, and that is, I have to build something relative to an imported model or some reference to an imported model, something I've gotten from someone else, a vendor, or something along those lines. And maybe I need to make a bracket or a flange or some miscellaneous piece that attaches to an imported model. And this is an example where we need to import the part into Onshape and then use a derived feature to embed that inside of its own part. So let me walk you through this. Let's just say, I have these bottom and top casing parts, and these are parasolids that I got from a vendor, for example, and I need to build a flange that joins these parts together. So I have them, they're two separate parasolids. I was sent two separate parasolids. I need to bring them together and then make my mating piece, right? And this is an example where the derived feature comes into play. So a very important thing to point out, you can import, into and build parts around imported models. You can also assemble parts in a part studio, which allows you to, model around other references, okay? So let me walk you through this. Let's start with Part Studio 1. And what I'd like to do is insert a derived feature. So I select derived, and then I select the parts that I'd like to insert. Now, this is an example of parts, but you can use the derived feature for a number of different things. It's not just inserting parts into part studios. It could be sketches or planes or a number of different things. So in this case, we'll start with the bottom case. I'll hit the green check OK. And now I have my first part embedded in my part studio. We'll do that one more time. Derived. We'll use the top case and then insert that as well. Okay, green check. And now I have inserted both parasolids into this one part studio, and I can begin building my mating part. One last thing I want to point out before I start modeling anything is that oftentimes you will have to move these parts in relationship to each other. The reason I bring this up is because these parts happen to be modeled in this orientation relative to the origin. They snap into place. If yours do not, you can transform and then move the part wherever you'd like. So this is how we manipulate parts. If you have a really complex scenario, the option I would choose is transform by mate connectors. It gives you very similar behavior to actually a mate in an assembly. But this is a way to assemble or move the parts relative to each other inside of the part studio. So only necessary if they don't import in the correct orientation or the way that you'd like them. Okay, so I mentioned before I've imported both parts. Now let's create a simple flange, right? So circle, I can constrain relative to the imported parts. I can, attach relationships, to edges and points of the imported parts. I can even convert edges using the use tool. So I've selected all 4 holes, convert them, and so it's really quick for me to go in and build something like a flange in this example that joins the 2 parts together, right? And all I did was reference the imported model. I don't need to go out and find the dimensions or all the values associated with it. Now, one of the biggest benefits to being a derived feature is the fact that it updates. Right? So if I were to go back to either of these parts and change them, the Part Studio where they're embedded or derived will automatically update. So let me walk you through this. Now, what I'd like to do is a move face, and we'll just make this outlet hole here just slightly smaller. Right? We'll do a 3/4 inch offset, and we'll do the same thing. So I'm just making that hole smaller. We'll do the same thing on the top casing. Quick move face, and we will move this in again 3/4 inch. Okay, so I've made the outlet hole smaller on both Part Studios. So when I go back to my Part Studio with the flange, the key thing here is they automatically update. So the derived features mean they're linked. And notice my flange diameter automatically updates because it was driven by the imported parts. So derived feature is very useful in situations like this where you're trying to reference imported parts multiple together. Maybe you need to build a bracket or some kind of, some piece that ties them together. You can use derived feature to embed the parts inside of Part Studio. Okay. So that is the derived feature. The next example, actually my last example here, is a U-bolt. So this example is strictly using a part as a tool. And there's no other purpose for this part besides construction of the finished end result. And all I'm going to do is, of course, subtract it from that finished end result. So let me walk you through how I might approach this. Now, an example of this might be a U-bolt, right? Where what I'd like to do is create a thread and then pattern the thread to the other side, right? So for this, we can do a sweep, and I can sweep the triangle along the helix. Okay, very simple. However, again, by default, it recognizes that the two are trying to merge and sets it to add. I want to set it to new, and this is a deliberate decision. You have to go and check new, and now I have a new part, which is just the thread sweep. Right? It has nothing else associated with it. It's just there for construction. Green check OK, and now I've got a part which is just there again for construction purposes. And remember, with parts, you can pattern them. So I can do a linear pattern, for instance, of this part, about, let's say, the right plane with 1.5 inch spacing. Okay. So now I've linear patterned this part to the other side to create the other thread. And so you can do this, and then you can even remove inside of the actual linear pattern if you choose to. So I don't have to do a separate Boolean. The linear pattern actually has the Booleans built into it. Green check OK. And now that thread, that tool is gone, but the thread remains. So again, the whole purpose of the sweep and the linear pattern was just construction to subtract the parts to create the thread profile. And again, in many cases, threads aren't necessary, but it's a great example of just using a part as a tool. In the end, the tool is gone. I don't see it in the finished result, but for a time, it was useful for construction purposes. Okay, so that is what I had planned for you today. I have a few last minute things I want to point out. If you have any questions, type them in. A few last notes for me. If you're just getting started in Onshape, we really encourage you to try Onshape in your professional work and let us know what you think of it. We'd love to hear from users. We have a feedback tool that's built into Onshape. You'll find it under the help menu. Type in anything you'd like. It's a very simple, easy way to give us feedback about your use of Onshape. So give it a shot, try it in your professional work, and really let us know what you think. The other things I always like to point out is invite others to Onshape. Share your documents. That's one of the easiest ways to do it. Even if they don't have an Onshape account, they've never heard of it, you can type in their email address and they automatically get created an account and sent a link to your model. So there's a big share button in the top right. Try it out. Type in their email address, hit share, and try collaborating in Onshape. The last thing I want to mention is, if you've been using it a while and you're interested in meeting local Onshape users, we'd love to hear from you. If you're interested in establishing and running your own user group, we'd love to hear from you. We'd love to help. So that's what I had planned. Again, I'm going to stick around and answer any questions that you have, so feel free to type them into the questions dialog. But that's it, everyone. Thank you for coming.